Hello there, everybody. In today's project, I want to look at document similarity analysis, and we're going to use Python, of course. I'm going to show you a couple examples. It's going to be focused mostly on my resume and one JD, which is a job description that I am applying for and interviewing for tomorrow. So I was talking to the recruiter today, and it occurred to me after I hung up that would probably be a good use case to compare how similar or how different my resume is to matching just job description. Okay, and I think this is going to be very interesting and very relevant for a bunch of purposes. Obviously, resume matching, semantic job matching, candidate ranking, talent intelligence, just helping HR people to work more efficiently, hopefully more responsibly, maybe more ethically too, AI recruiting, document similarity. And where's this used? All over the place. Like this specific scenario that I'm describing is certainly relevant to applicant tracking systems, job boards, intranet, talent matching, portals, recruiter tools, staffing agencies, so on and so forth. But keep an open mind. This is just one example matching one resume to one job description, right? This could be used in all kinds of different sectors, aviation, any kind of financial application, manufacturing, government, education. There's so many uses. This is just one that I came up with, but hopefully it inspires you to come up with your own similar case studies or analysis or whatever you're doing over there. And then and I'll show you at the end how to manipulate some things very quick and easy so you can literally use this in any kind of work environment. Okay, so we're going to look at a couple different things: TF-IDF and cosine similarity. So cosine similarity measures the mathematical relationship between different types of text. So if it's very similar, you'll see a small movement like this. If it's very not related, you'll see almost like a 90-degree angle. And if they have no relationship whatsoever, it's going to be like two arrows pointing away from each other, going in opposite directions. Okay, and TF-IDF is for short for text frequency and verse document frequency. This is how frequently words show up in text, and we're comparing that, right? Because we're comparing what's in the resume to what's in the JD. And IDF is inverse document frequency. This is the inverse of how frequently text shows up, right? So if a word doesn't show up too much, that would be indicative of that document not being very important for that word. If that word shows up all the time, it could be Apple or something. This could be an Apple sales report, Apple news event or something like that, right? Or Microsoft. You can imagine how many ways you can go with it. And I have some notes over here. TF-IDF is simple. It's very fast, easy to interpret. No contextual understanding whatsoever, okay? And there's no forecasting or time series. It just doesn't work like that. You can't recognize systems or synonyms or paraphrases, right? With a large language model, I'm going to show you in just a minute, you can. And it's sensitive to word ordering or phrasing, okay? I'm going to show you the TF-IDF plus cosine similarity and compare that to a large language model that uses embeddings and cosine similarity. This converts entire sentences or paragraphs into dense dimensional vectors. Okay, there's embedding capture semantics, not just words, but what word will come after another word, and what is the pattern of the overall sentence and the whole paragraph and the whole document too, right? So large language models can capture that very easily. With cosine similarity and TF-IDF, it just doesn't, right? So there's more meaning, there's more intent, there's more nuances, and the model will understand that. And it works well in larger, longer texts, okay? So that's great. And it does fuzzy matching in real-world use cases, but it's a little bit slower, not that slow, it's still very fast, you're going to see. And it's harder to interpret the vectors directly, right? So you just have to trust the model. This is one of these black box models where you give it a very simple scenario and you understand how it works, but when you apply it on a much more complex scenario, you'll still understand how it works, but how does it get to the final recommendation that the model makes? It's very hard to prove. Like, you can understand it on a very simple case, but to take that simple case and make it much more complex and say the model performs these mathematics and I get this result for this reason, that's hard to do, okay? So there's a couple ways we can do this. I can read in the data from a file that's sitting on my desktop. This is my resume, and this is the job description. I'm going to do a little text cleaning on that, and then compare the resume text, which I have right here. It comes down here, to the job text, which is right here. Okay, there's the job text, and the TF-IDF fit transformer is going to do the lift for us. So I hit Control Enter, and it says the similarity is 0.2637. So it says my resume is not matching this job very closely. It's only 26% match. So there's two things that come to mind. Either the language on my resume is not right to match the job, right? That's something that I might want to look at and try to pick out keywords from the resume and I'm sorry, from the JD and put that on my resume. I could certainly do that and boost this number a little bit. And also, this might not be the best approach because I just told you that the cosine similarity and TF-IDF are good at this, but a large language model is going to perform much better in this kind of scenario. Okay, so let's look at the LLM right here. I'm using this version right here. This comes from Hugging Face Transformers. If I do Control C, Control V over here, if I want to see some of these other models, I can put that in Google. Sentence Transformer, that's exactly what I'm looking for. Okay, and we have a bunch of models to pick from. We have sentence similarity, text embedding, inference, sentence transformers. This I think is that everything or what? Let me see. No, that's something else. I was looking for the count of the models because I have quite a few. You can see that there have been over 89 million downloads since last month. So this site is getting slammed with requests for new models. Let me see if I go over here. Because somewhere over here, they have a count of all the models that they have. Oh, I think this is it. Wow, that's big. Okay, I thought it was like hundreds of thousands. So now they're up to 1.561858 models, so 1.5 million different models, and you can search for the different model by name over here. This is the model I'm using. This one tends to perform pretty well, but you can see there's all kinds of alternatives too. So if you're not getting the performance you want or the output you want from this one model, go ahead and try others. I think these are all free, and they're all good. Oh, so 384 models for that specific type, and then you go back over here and 1.56 million. So you will probably run out of time before you run out of models to test. There's a lot. So, okay, so I pulled in the model. Here's my resume. I'm going to copy and paste the text into this Jupyter Notebook cell and run it. Okay, so this is my resume over here. So that's one input. This is the job description. That's another input. And then I'm going to run the model and see what the similarity scores are. And I'm getting 0.3855. So that's a little bit better. That's significantly better than what I got over here. This is 26% match between these two, but we're using a more sophisticated model. I didn't change anything on my resume or in the document, and we're getting a higher output over here, 38.55. And then what else? And if I run this over the document using the read-in method, right? Because I can also read in the files from my desktop. I'm getting 38.55, so exactly the same outcome. And we can test a couple things over here too. If I wanted to just cut this out and this right here, just to make the text very, very similar, I'll show you how this works, because if you do have slight differences, you will have different outputs, right? And that is my resume. Okay, so let me get rid of that. So if I run that and then that, and then refresh the model, large language model says it's 100% accurate, right? And that makes sense because it's two identical things. So if I put this as I dropped the Android, I don't have to change that because that's not changing. I'll change this input, and now it's 91% similar. And if I change, obviously, more things down here, apple, banana, that's totally different, right? So I would expect a lower score over here when I compare those and run the model, and it's lower. And you can see it's very sensitive too. Now we only have 4 lines of text and change one entire word, And now the documents are only 79% similar, right? And that's very interesting to me because they do have to be very, very similar to get a very high score. These, when you look at it, like for a person, you'd probably say, yeah, this is pretty similar. Obviously, this word is different from this word, but the other 3 lines are exactly the same, right? But still, it's just over 79% accurate, or 79% match. 79% match. So it's 20%. 20% different. These 2 documents are 20% different. So that's it. I think we'll wrap it up here. That's what I want to show you. I will share this code with you guys as always, and I will post a video when I post it later today. This is a short one, just 10 minutes. I have some notes down here. Just a couple things that I noticed. If you have some inconsistencies like I just showed you right there, even changing one word can change the output quite a bit. It can go from 100% to 91 to 79. That's what we saw. But also there could be hidden line breaks. There could be extra white space, headers, footers, things like that. So that is going to lower the score too. Just something to be aware of, okay? And it's not bad and it's not good. That's just how these models work. That's just how it works, okay? So I'm going to wrap it up. I'll post this code. I will share the video later today, and you guys will have everything you need when you download this code as an HTML file. You can upload it, or you can open it and copy and paste that into your Jupyter Notebook. You can even convert the HTML file into Jupyter Notebook and just run it as is. So that's what I wanted to show you. Document similarity analysis using Python. That's it. Thanks for your time, guys, and enjoy the rest of your day. Bye.